Every single day, our biology offers us a window of opportunity to control the trajectory of our energy, focus, and mood. But most people drift through their mornings without activating the key systems that set the brain and body on the path to optimal productivity. The first few hours after waking are biologically primed for harnessing neurochemicals that sharpen attention, elevate alertness, and enhance physical readiness. That's not a motivational phrase. It's rooted in the science of circadian biology and neuromodulation. The tools we apply early in the day determine the level of clarity and performance we can access throughout the rest of it. Getting sunlight exposure within 30 to 60 minutes of waking is one of the most potent tools for regulating the body's internal clock and optimizing both brain and body function throughout the day. This isn't a vague wellness suggestion. It's a precision-based protocol rooted in circadian neuroscience. The human body operates on a roughly 24-hour cycle known as the circadian rhythm, which governs everything from hormone release to temperature regulation to mood and cognitive function. At the center of this system is a structure in the brain called the suprachiasmatic nucleus, located in the hypothalamus. This region receives input directly from specialized retinal ganglion cells in the eye that are sensitive to blue light. These cells communicate light presence, not visual scenes, to the brain's master clock, signaling that the day has begun and triggering a cascade of hormonal and neural responses designed to align the body with the external environment. When sunlight enters the eyes in the early part of the day, especially during the first hour after waking, it causes a timed increase in cortisol, a key alertness hormone. Contrary to popular belief, cortisol is not inherently negative. When released at the right time, like in the morning, it plays a critical role in boosting focus, increasing energy availability, and priming the body's immune system. This early cortisol pulse also sets the timer for the evening release of melatonin, the hormone responsible for sleepiness. That means morning sunlight doesn't just affect the current state, it determines how well you'll fall asleep and stay asleep that night. The light also affects dopamine production pathways, which directly contribute to mood elevation and motivation. Studies show that people who get regular morning sunlight report better mood, more energy, and greater productivity. Artificial light is not a substitute. Indoor lighting, even bright bulbs, typically falls short of the intensity needed to activate the proper retinal and brain pathways. Outdoor sunlight, even on a cloudy day, provides far more lux, a measure of light intensity, than indoor environments. Where indoor lighting might offer 300 to 500 lux, natural sunlight delivers anywhere from 10 Zalausen to over 100 Zalausen lux depending on conditions. That level of stimulation is what the retinal ganglion cells require to reset the clock properly. It's not about looking directly at the sun, which is unsafe. Rather, it's about being outside, allowing ambient light to enter the eyes indirectly while avoiding sunglasses in the first few minutes to maximize signal strength. This practice is particularly crucial in the early hours of the day because the brain is most sensitive to light during that window. Delaying sunlight exposure by even a few hours can shift the circadian rhythm in ways that impair energy, focus, and sleep. For those who live in locations where early morning light isn't available, especially in winter months, a bright light therapy box that emits 10,000 lux can serve as a secondary tool, though natural light remains superior. The goal is consistency. Getting light at roughly the same time each morning trains the brain and body to expect alertness at a predictable rhythm, creating a solid biological foundation for focus, clarity, and mental resilience. Engaging in 10 to 20 minutes of high-intensity movement early in the day, a direct way to unlock your brain's optimal performance circuits and prime your body for sustained energy and focus. Physical activity is not just about muscle and endurance. It's a neurological signal that shapes how alert, motivated, and emotionally regulated you are. When the body is pushed into effortful movement, even briefly, it sends immediate feedback to the brain through a flood of neurochemicals. Chief among these are dopamine, norepinephrine, and endorphins. These are the very chemicals that increase motivation, heighten attention, and create a sense of mental clarity. A short but intense workout in the morning is like flipping the brain's on switch. It doesn't require hours in the gym. Bodyweight circuits, short sprints, jump rope intervals, kettlebell swings, or even fast-paced shadowboxing can activate the same neural pathways. The key is effort, not duration. When the brain senses that the body is under load, it responds by increasing neural firing speed and enhancing communication between motor and cognitive regions. This kind of deliberate movement also engages the prefrontal cortex and the basal ganglia, regions responsible for planning, goal-directed behavior, and habit formation. Early movement creates a neurochemical context where tasks feel more doable and obstacles feel more manageable. It shifts the brain into a state of readiness. It's not just the increase in wakefulness, but the alignment of mental and physical systems that makes this practice so effective. When done regularly, it conditions the nervous system to expect action early in the day, making it easier to transition into productive work states. This effect is amplified by the timing. Exercising in the early part of the day takes advantage of a natural rise in core body temperature, which supports muscle activation, joint mobility, and metabolic efficiency. It also aligns with the natural peak in cortisol, enhancing the energizing effects without causing excessive stress. In addition to the immediate boost in alertness and performance, high-intensity morning movement has longer-term effects. It enhances the brain's ability to adapt through neuroplasticity, especially when paired with learning or focused work that follows the session. Studies have shown that physical exertion triggers the release of brain-derived neurotrophic factors, BDNF, a molecule that supports neuron growth and cognitive resilience. This means you're not just waking up the brain, you're actively strengthening its capacity to grow and adapt. Another major advantage is the role that early movement plays in mood regulation. The elevation in dopamine and endorphins creates a buffer against stress and anxiety, making it easier to stay emotionally stable through the challenges of the day. This practice also entrains discipline. When you push your body to move under tension first thing in the morning, you're training the brain to associate discomfort with reward. That association reshapes the limbic system over time, making it easier to engage with difficult tasks in other domains of life. The result is not just a fitter body, but a mind that is wired for effort, consistency, and follow through. Hydrating immediately upon waking and delaying caffeine by 90 to 120 minutes is a foundational protocol for maintaining stable energy, enhancing mental clarity, and supporting the body's natural biochemical rhythms. Overnight, the body loses a significant amount of water through respiration and perspiration. This creates a state of mild dehydration that, if not corrected early in the day, impairs brain function, slows metabolic processes, and disrupts the delicate balance of electrolytes that govern nerve signaling and muscle contraction. The brain, being composed largely of water, is especially sensitive to hydration levels. Even a small percentage drop in hydration status can lead to fatigue, impaired concentration, and headaches. Rehydrating first thing in the morning replenishes fluid levels and supports the activation of the systems responsible for attention, reaction time, and working memory. To maximize the effectiveness of this hydration protocol, it's beneficial to include electrolytes, specifically sodium, potassium, and magnesium in the water. These minerals are essential for proper nerve transmission and muscular coordination, and they also help cells retain the water you consume. A simple pinch of high-quality sea salt or a dedicated electrolyte mix can dramatically increase the absorption and utility of your morning hydration. This step is particularly important for people who sweat a lot during sleep or those who follow low-carbohydrate diets, which tend to deplete electrolyte stores more rapidly. Hydration isn't just about volume. It's about fluid balance at the cellular level, and electrolytes are what allow that balance to be restored and maintained. Caffeine, though widely used to stimulate alertness and improve performance, can be counterproductive if consumed too early after waking. When you first wake up, levels of a molecule called adenosine are relatively low, and cortisol levels are beginning to rise naturally as part of the circadian rhythm. Cortisol provides a potent and healthy alerting signal, and early caffeine intake can interfere with this natural spike, leading to a diminished response over time and potential disruption of cortisol's role in setting the body's internal clock. More importantly, consuming caffeine too early temporarily masks adenosine, the molecule that builds up throughout the day to create sleep pressure, rather than allowing it to be naturally cleared by the body. When the caffeine wears off, adenosine rushes back in, often leading to the classic afternoon crash in energy and mental clarity. By delaying caffeine intake for 90 to 120 minutes after waking, you allow adenosine to be naturally metabolized and cortisol to rise unimpeded. This supports a smoother, more sustained energy curve and better cognitive performance throughout the day. It also reduces the likelihood of caffeine dependency and enhances its performance, boosting effects when it is finally introduced. When caffeine is consumed later in the morning, ideally after hydration and some light movement, it acts more like a turbocharge than a crutch, enhancing focus without creating jitteriness or dependency. This simple shift in timing transforms caffeine from a blunt instrument into a precise tool for cognitive optimization, and when combined with morning hydration, it sets the stage for peak performance across the rest of the day's demands. Eating a high-protein, low-sugar breakfast is one of the most effective ways to support neurotransmitter function, regulate energy levels, and maintain cognitive stability throughout the day. After an overnight fast, the body and brain are in a state of heightened sensitivity to nutrients. What you consume in your first meal sends powerful signals to your metabolic and neural systems, influencing how you feel, think, and perform for hours to come. Protein, especially when consumed early in the day, provides the amino acid building blocks required for the synthesis of critical brain chemicals like dopamine, serotonin, and acetylcholine. These neurotransmitters regulate motivation, mood, attention, and memory. When the brain is deprived of these raw materials, even subtle shifts in focus, emotional stability, and task initiation can occur. A high-protein meal delivers the necessary inputs to keep the brain's chemical machinery running smoothly. Equally important is the avoidance of excessive sugars and high glycemic carbohydrates at breakfast. While sugar-rich foods can create a short-lived spike in energy, they are followed by a rapid crash in blood glucose that triggers fatigue, irritability, and cravings. This crash activates the sympathetic nervous system, also known as the stress response, which elevates cortisol and leads to brain fog or jitteriness. When this pattern repeats day after day, it creates metabolic instability and contributes to insulin resistance, which is directly linked to impaired cognition and long-term brain health challenges. In contrast, a low-sugar, high-protein breakfast leads to a slower, more stable release of glucose into the bloodstream. This supports balanced insulin signaling, stable energy, and a calm yet focused mental state that is ideal for deep work and complex problem solving. Including fats and fiber alongside protein further stabilizes energy by slowing digestion and prolonging satiety. This reduces the likelihood of needing a mid-morning snack or caffeine surge to maintain alertness. Healthy fats, such as those found in eggs, avocados, or nuts, support the formation of neuronal membranes and facilitate the absorption of fat-soluble vitamins, all of which contribute to cognitive resilience. Fiber from vegetables or seeds helps modulate the release of glucose and feeds gut bacteria, which in turn produce metabolites that influence mood and brain function. The gut-brain axis plays a critical role in regulating inflammation, neurotransmitter production, and stress responses. A stable microbiome starts with stable nutrition, and the first meal of the day is your opportunity to send the right signals to that system. Another often overlooked benefit of a high-protein, low-sugar breakfast is its impact on decision-making and willpower. Stable blood sugar and elevated dopamine levels increase the likelihood of making disciplined, high-quality choices throughout the rest of the day. This is particularly important for individuals who are engaged in mentally demanding work or physical training, as cognitive endurance and physical performance both depend on a steady stream of mental resources. Skipping breakfast or consuming one high in sugar undermines the ability to sustain peak output across the brain's executive networks. A well-structured morning meal acts as a strategic input that aligns metabolism, neurotransmission, and behavioral control toward a more productive and focused day. Using breathwork techniques like cyclic sighing and integrating panoramic vision breaks throughout the day are simple yet biologically powerful ways to regulate stress, restore mental clarity, and recalibrate the nervous system for optimal performance. The autonomic nervous system, which governs our stress and relaxation states, operates largely outside of conscious control, but breathing is one of the few levers we can consciously manipulate to access it. Cyclic sighing, a protocol consisting of a double inhale through the nose followed by a long, extended exhale through the mouth, has been shown in both laboratory and real-world conditions to reduce autonomic arousal more effectively than other breathwork techniques. The first inhale fills the lungs partially, the second finishes the inflation and stretches the alveoli, while the slow exhale activates the parasympathetic branch of the nervous system, signaling the brain and body to downshift from high alert into a more calm and focused state. When practiced for just 1 to 3 minutes, cyclic sign can rapidly lower levels of stress hormones like cortisol and shift heart rate variability, a key marker of resilience and nervous system flexibility, into more favorable ranges. Unlike meditation, which can take weeks to show measurable changes, cyclic sighing provides immediate relief and is accessible to anyone regardless of experience. It is particularly effective when used at transition points in the day, before a high-stakes task, after a stressful interaction, or between work sessions. These moments are critical inflection points where cognitive performance is often compromised by lingering stress signals or overstimulation. Instead of waiting for calm to return passively, breathwork gives you agency over your internal state and allows you to reset the system on demand. In parallel to breath control, the visual system plays a central role in modulating the nervous system. When you're focused on a screen or narrow visual field for extended periods, the brain enters a mode associated with heightened alertness and sympathetic tone. This narrow focus is useful for tasks requiring precision and detail, but when sustained too long, it contributes to visual fatigue, cognitive burnout, and elevated stress. Deliberately shifting the eyes to a panoramic mode, looking at a wide, distant horizon, or even just gazing out a window at the sky sends a signal to the brain that it is safe to relax. This is not metaphorical. It is based on hardwired neural pathways linking eye movement to state regulation. Panoramic vision activates circuits in the midbrain that reduce sympathetic arousal and restore balance to the nervous system. Incorporating panoramic vision breaks for just 1 to 2 minutes every 90 minutes of focused work acts like a biological pressure release valve. It prevents the accumulation of mental and physiological tension that often leads to errors, fatigue, or decreased productivity. Combining this with breathwork compounds the effect, creating a feedback loop of regulation that supports sustained cognitive output. These protocols are minimal in time investment but maximal in impact, allowing for real-time stress recalibration and maintaining a high-performance state across even the most demanding days. Maintaining consistent sleep and wake times is one of the most powerful levers for optimizing cognitive function, emotional regulation, and physical recovery. The human brain and body operate on circadian rhythms, which are tightly synchronized to environmental cues, primarily light and darkness. When sleep and wake times shift inconsistently, the internal clock begins to lose alignment with these cues, leading to a cascade of disruptions in hormone secretion, body temperature, neurotransmitter activity, and gene expression. These disruptions don't just affect sleep quality, they affect how well the brain performs during the day. Inconsistent sleep patterns can impair memory consolidation, reduce attention span, increase impulsivity, and weaken emotional resilience. On the other hand, a consistent sleep-wake rhythm builds a reliable foundation for both neural plasticity and metabolic efficiency. Cortisol, melatonin, and growth hormone are all released in precise timing windows that anticipate your sleep and wake behavior. When you maintain regularity in sleep and wake times, the body learns to predict when to be alert and when to prepare for rest, and this predictability enhances the quality of sleep architecture, especially deep sleep and REM sleep. Deep sleep is when the brain clears out metabolic waste via the glymphatic system, and REM sleep is when emotional memories are processed and creativity circuits are activated. Fragmented or delayed sleep disrupts these phases, leaving the brain recovered and the body physiologically stressed, even if the total hours of sleep appear sufficient. A consistent rhythm enhances the amplitude and coordination of these cycles, making sleep not just longer but more restorative. Wake time is particularly important as it sets the tone for the entire circadian rhythm. Waking at different hours each day, even by 60 to 90 minutes, can delay melatonin onset the following night, which delays sleep and shortens deep sleep duration. This results in a circadian misalignment that mimics the effects of mild jet lag, including fatigue, irritability, impaired memory, and difficulty with focus. In contrast, anchoring your wake time within the same 30-minute window each day, including weekends, provides a stable signal to the brain that helps align other biological rhythms such as hormone release, body temperature cycles, and feeding behavior. This is why wake time regularity is often more critical than sleep time consistency, especially when full sleep duration isn't always possible due to lifestyle constraints. In addition to cognitive and hormonal optimization, Consistent sleep and wake times dramatically influence immune system function, cardiovascular health, and mood regulation. Irregular sleep patterns are linked to elevated inflammation, insulin resistance, and increased risk of anxiety and depression. Conversely, consistent rhythms support better glucose regulation, enhance mitochondrial function, and increase the sensitivity of dopamine receptors in the brain's reward pathways, which can improve motivation and reduce the likelihood of burnout. These biological effects are not just long-term. They show up within days of implementing a regular schedule. The brain and body thrive on rhythm, and sleep is the master signal that orchestrates everything from gene expression to psychological resilience. Establishing a non-negotiable window for both bedtime and wake time is one of the lowest cost, highest return practices for anyone looking to enhance performance across cognitive, emotional, and physical domains.